Let's talk about laying out a solar array on a composition shingle roof. I'm going to walk you through the process of the layout, array measurements, but I'm also going to show you some of the tools that I like to use and what you're going to need on the roof to complete that process. Let's start right at the beginning and follow the order of operations of how you're going to actually install and lay out the array. So you're going to need a measuring tape, something like a 30-footer, 35-footer, something I like to use so that it's sturdy. You can lay out longer dimensions. You can use crayon or chalk to mark your measurements. I like to use chalk because it'll wash away easier. If you're using crayon, it might stay up there for a little longer. You don't want the homeowner looking up at that a couple months after you come away from an installation. You're also going to need a chalk line to strike lines on the roof. I like to use the 100-foot extra bold style, so it creates a nice thick line. Easy to see. You can also use these little guys, a little bit thinner, but they do fit right in a pouch or pocket. You know, also depending on the roof covering, the color of your shingles, use something that you can see easily. So like I said, if it's a tan, use a darker color. If it's a darker grayish, you can use something high visibility like an orange. Next task is going to be to find rafters. There's a few ways to do it. The easiest way to do it is to just get up on the roof and start knocking with a hammer, and you can feel the difference between the sheathing versus the structural components. So a hammer is a good way to do it. I like to use this, it's called an RSC bar from Estwing, because it can do a couple different things. When you're attaching on a shingle roof, you're going to want to be prying shingles, so it has that built in, but also has a head that you can knock around and use as a hammer, and it's a little bit more accurate because it has a thinner profile. When attaching to rafters, the most common lag screw used is going to be this 5/16 diameter lag bolt. So to put that into the wood, you're going to want to drill pilot holes so that you're not blowing out the rafter truss below it. You're going to want to use a 7/32 drill bit for that so that you have enough bite still, but you're not too loose. You won't pull out of the rafter, but you're also you don't have too small of a diameter hole where you are going to crack the wood. Before you even get up on the roof to draw out your layout, you're going to want to refer to your plan sets. So here's an example plan set. Real general, gives you array location, roof dimensions, electrical diagram. And at K2 we also provide what we call our base report. You can go online on our website, and it's our design tool. So you plug in your location, some information about the array, and it does all the engineering for you. Gives you your array dimensions, roof dimensions, mounting spans, bill of materials, all that is included. So the plans will tell you which orientation your modules are going to be laid out in, whether that's portrait or landscape. Landscape being the long side of the module is running parallel with the ridge and the eave of the roof, portrait being the long side of the module running perpendicular with the ridge. Now that we've reviewed the plan set and found where our array is going to be located on the roof, we're going to go through how you're going to lay that out. So if the plans call out that you're centered with your array on the roof, you can measure out the total length of the roof and then find your center point, and based off of that center point, mark out your array dimensions. If your array isn't centered on the roof, for whatever reason, shading, aesthetics, you can just pick a reference point. Like usually it would be off of one rake edge of the roof, and that's how you're going to get your module corners marked out to keep it nice and square. Depending on whether you're mounting in landscape or portrait, you're going to have a different way of measuring out the total length of your array. We'll take portrait for example. Portrait array, you're going to want to multiply the module width by the number of modules in your row. So we'll say we have a 40-inch wide module, multiply that by, you have 4 modules in a row, you get 160 inches of total length of your array. But then you're going to want to count for the module gaps created by your mid clamps. So you take that mid clamp gap, multiply that by the number of gaps in your row, which is 3, and you add that to your total length, and that'll be your total length for the row of modules. If you design your system in K2 Base, it has the engineering built in to help you determine whether you want to use a deck attached or a rafter attached system, depending on your region. It'll also provide a bill of materials, tell you how many mounts you need, where those mounts are going to be located, and your max span for those mounts. When you're attaching mounts to structural members, first thing you want to do is find a couple adjacent rafters. Usually rafters are going to be either 24 inches on center or 16 inches on center. And typically within the building, though, that spacing is going to be uniform. There is the rare case where rafter spacing will change, so it's always best practice after you mark them out to just double check with a hammer and make sure you're on a rafter. If you're attaching your mounts to the decking of the roof, the upside to that is you can basically put the mounts wherever you want. You're not limited to attaching them over top of rafters. The downside is it's not going to be as strong as attaching to rafters. So you're talking about grabbing about a ½ inch of wood sheathing versus 3 inches of solid wood. You're going to need extra screws to grab that sheathing to get the same pull-out strength as the solid wood. The other thing to keep in mind is that you might need to get more materials because the max span called out by attaching to the decking might be shorter than attaching to a rafter. There's a couple differences between the fasteners you're going to attach your mounts with. Here's a 5/16 diameter lag bolt, 4 inches long. It's going to grab 3 inches of embedment, usually of your 2x4, 2x6 rafter. And here is your deck attachment wood screw. It's a 60 millimeter by 5 millimeter diameter. The nice thing about our splice foot is that it can do either. You have the option to do 4 of these wood screws into the corners for a sheathing attachment, or you can use 2 of these in line with your rafter for a rafter attachment.